Today mainly we will discuss that valence bond theory of that complex compound. Now what is the learning objective? To understand that hybridization and that shape of the molecule and magnetic property. What are the keyword? Now square planar complex, octahedral, then tetrahedral, diamagnetic, paramagnetic. These are the keyword. Now few points you have to remember in VV theory. First one, that D system. In any given complex, first we have to identify what is the D system. Now for this, one simple things we have to remember. Now see that scandium, titanium, vanadium, chromium, that means 3D series. That one we have to remember, because when it is given Fe2 plus, directly it should that come in our mind that it is a D6 system. Okay, so for that you remember this thing, scandium 2 plus na D1 system, titanium 2 plus D2 system, vanadium D3, scandium, titanium, vanadium, chromium, that is D4. In that way, manganese 2 plus D5. Okay, after manganese, see iron 2 plus D6. Okay, then cobalt 2 plus D7, nickel 2 plus D8, copper 2 plus that D9, and that zinc 2 plus D10. That things we have to remember. Okay, first point. Second point, na strength of that ligand. Because see, in presence of strong ligand, that is electron are in pair up condition, it will show low spin complex. So strong ligand, it will form low spin complex. Low spin spin complex. Now what are the strong ligand? Generally which contain carbon. For example, Cn minus, CO. Okay, these two mainly will use as a strong ligand. Now the only problem with moderately that strong ligand, for example ammonia. In some case ammonia act as a weak ligand, in some case it is strong ligand. Mainly if the oxidation number of that central metal is higher, then ammonia act as a strong ligand. For example, see cobalt NH3 whole 6 3 plus. In that case, see that cobalt 3 plus higher oxidation state, so ammonia act as a strong ligand. Okay, so moderately active ligand, that you have to remember, in which case it is strong, in which case it is act as a weak ligand. And weak ligand, which are weak ligand? Now see, all halogen, water, these are weak ligand. And weak ligand, high spin complex. Okay, weak ligand, high spin complex. That means electron are in that unpair condition. And low spin means electron are in pair up condition. Okay. Third point, say na hybridization. Now in case of C complex, na generally sp3 dsp2 sp3d2 or d2sp3, within these four you will get. Okay, other are possible, but in our syllabus mainly these four type that hybridization that is asked. Okay, three things you have to find. One is hybridization, second one it's geometry, third one magnetic property, that is it is paramagnetic or diamagnetic. So just these three things remember. Say sp3, sp3 means it is tetrahedral. Now second one dsp2, na square planar. Then d2sp3, that one octahedral. but inner D complex. Another one sp3d2, that is also octahedral but outer D complex. So only these four probability you have to remember: sp3, dsp2, d2sp3 and sp3d2. And that fourth one is magnetic property. Now magnetic property say, if it contain unpaired electron, paramagnetic. If it does not contain unpaired electron, it is diamagnetic. Okay. Next we will discuss few example. Now see, first one, that NiCO whole 4. Now NiCO whole 4, see, now in that case key, nickel oxidation state 0. So oxidation state 0 means 3d8 4s2. Now CO strong ligand. So see, electron are in pair up condition. That two electron from that 4s that shift to that 3d. So actually it is 3d10. 3d8 4s2, but as CO strong ligand, so what happened? All the 10 electron are in pair up condition in that 3d that subcell. Okay. Now how many ligand? 4 ligand. So 4 box we need. So that's why the hybridization is sp3. Now sp3 means shape is tetrahedral, no unpaired electron, so it is diamagnetic. And to find that magnetic moment, say, remember that formula: under root n into n plus 2, where n is the number of unpaired electron, where n is the number of unpaired electron. NiCN whole 4 2 minus, NiCN whole 4 2 minus. So see, Ni2 plus, first step, Ni2 plus means D8 system. Now Cn, strong ligand, strong ligand. Okay, strong ligand means that electron are in pair of condition. Okay, so see, 1 2 3 4 5 6 7 8. So how many ligand? 4. So 4 box, that is 3D, that is 4s, and this one 4p. Now 3 box we need, sorry, total 4 box, 4 ligand. So dsp2 means square planar. And see, in that case no unpaired electron, so diamagnetic. Next see, that NiCl4 2 minus. Now Ni2 plus D8 system. Now chlorine weak ligand. So see, all that 5 that subcell of the 3D that occupied the 5 orbital. Now that how many ligand? 4. So the hybridization is sp3. First step, D system, Ni2 plus D8. Then chlorine weak ligand. So normal arrangement, first singly fill up, then that pair, that Hunsul, first singly fill up, after that pairing. Now in that case, two unpaired electron, that's why paramagnetic. So sp3 tetrahedral and magnetic property paramagnetic. Next one, see, that COF6 3 minus. Now see, cobalt 3 plus, fluorine weak ligand, cobalt 3 plus means D6 system. See, electron arranged in that way. Now 6 box we need. So see, 1s, that 1s orbital, then 3p orbital and 2d orbital. Now in that case, see, that sp3d2. Now sp3d2, as it used that 4d orbital in hybridization, it is outer D complex. So COF6 3 minus, it shows outer D complex. Okay, CO NH3 whole 6 3 plus. So cobalt 3 plus, D6 system. Now ammonia higher oxidation state, so act as a strong ligand. Strong ligand. Now in that case, say 1, 2, 3, 4, 5, 6. So we need say 1, 2, 3, 4, 5, 6. So D2 sp3 inert D complex, octahedral inert D complex, because it used 3d orbital for hybridization. So CuNH3 whole 6, that 3 plus inert D complex. Now in that case no unpaired electron, so diamagnetic. Octahedral inert D complex, diamagnetic, and hybridization is D2 sp3. So in that way, see, just remember, practice these few example for that VB theory. That much is okay. Okay, sure. To tell this much.